Hey everyone, welcome to The Explainer. Today, we are absolutely pulling back the curtain on what I like to call the invisible digital engine. We're talking about the fundamentals of modern database systems. It's the fascinating, hidden architecture humming quietly in the background of literally everything we do online. Just think about your morning routine for a second. How do apps like Facebook, YouTube, Instagram, or even your online banking app, how do they store millions and millions of users' data and recall it in milliseconds? I mean, it kind of feels like magic, right? But the answer is actually incredibly elegant, and it's the foundation of everything we're diving into today: databases. Okay, let's dive into this. At its absolute core, a database is simply an organized collection of data. It allows information to be stored, managed, updated, and retrieved super efficiently. It is not just about storage, you know? It's about doing all of that at a massive scale, because without that structural organization, trying to find a single banking record, yeah, that'd be like trying to find a digital needle in a massive haystack. Now, what's really interesting about this concept is if you think of it like the ultimate digital library. So a physical library stores physical books, right? But a digital library, it stores your user accounts, your videos, messages, products, transactions, the whole shebang. And where a physical library uses the Dewey Decimal System to keep things organized, a database uses a highly structured architecture, so all that digital stuff can be recalled instantly. And this brilliantly illustrates how it actually looks in practice, using a school database as an example. You've got columns that define specific attributes, things like student ID, name, age, course, and email. And then each row represents an individual student. It's like a giant super smart grid. This structure lets the system cross-reference data points in literally a fraction of a second, making sure every single piece of information has a designated, easily queryable home. All right, moving right along to section 1, how data actually moves. So to actually move all this data around, we rely on the DBMS, which stands for Database Management System. Think of the database itself as just passive storage. The DBMS, well, that's the crucial middleman. It's like the ultra-efficient librarian that processes your requests, interacts directly with the database, and then hands the results right back to the application. It really does all the heavy lifting. It's essentially a rapid-fire relay race, basically the journey of a single click. Let's break it down step by step. Step 1, the user sends a request. Step 2, the app communicates that request to the DBMS. Step 3, the DBMS processes it, diving in to retrieve or store the data. And finally, step 4, the DBF returns the exact result back to the app. And all of that is happening in milliseconds. Crazy, right?
Which brings us to section 2, benefits and database types.
There are basically 5 core benefits that make these systems absolutely non-negotiable for developers. We're talking organized storage, fast retrieval, consistency, security, and scalability. They keep your data cleanly formatted, they let you grab it instantly, they prevent annoying duplication, they protect your sensitive info with strict access controls, and, maybe most importantly, they scale right along with the business as it expands. Let's move to and see how this builds into the different flavors of databases developers actually use. First, you have relational databases like MySQL. These use very strict, rigid tables for maximum consistency. Then you have NoSQL like MongoDB, which is way more flexible, perfect for unstructured data. And finally, in-memory databases like Redis. These bypass the hard drive entirely and store data directly in RAM for lightning-fast access. Basically, the job dictates the tool. Let's take this out of the abstract. Section 3, databases in the real world. This invisible engine is everywhere, powering the massive institutions in our daily lives. Banks use them to manage accounts and process millions of transactions flawlessly. E-commerce platforms, they rely on databases for products and payments, especially during huge order surges. Hospitals depend on them to instantly pull critical patient records without any overlap. And schools use them for attendance and grades across thousands of students. Modern society literally runs on this architecture. So the crucial point here is exactly this quote. Databases are the foundation of modern software and digital services. Without these systems quietly working in the background, keeping everything organized and accessible, almost every website and app we use would just, well, they'd simply collapse under their own weight. Understanding databases is truly the absolute first step toward becoming a developer, a data analyst, or a software engineer. The invisible engine isn't so invisible anymore, is it? But as our digital footprint keeps expanding, the challenge shifts to handling things like AI and real-time edge computing. So, with all these evolving tools at your fingertips, what will you build next?